Hello, let's continue our Sudoku adventure with Cages and More Cages by Strosahl. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have cages in the grid, that are these cells surrounded by dotted lines. Whether the cage has a letter or a number, digits cannot repeat in a cage. So if this was a 2, this Sudoku would say this should be able to be a 2, but the cage says no. The cage says no, you can't repeat that digit. So digits don't repeat in any of these cages, within the cages. In addition to that, the cages with numbers in the top left are killer cages. So the digits in the cage sum to the value in the top left. So these sum to 7, these sum to 15. We also have reflected cages. It took me, I looked at this before recording. It took me a bit to understand what flipped meant or reflection meant, but I think I get it now. So the cages that are labeled with a letter have the same digits as each other in the same relative positions, but with reflection. When we say with reflection, and it's not rotated, what we need to do is we need to reflect across the X and Y axis. We need to reflect across both axes. So the example is this digit, row 2, column 3. We need to reflect it basically across this diagonal here, right? We would reflect it across the, we would reflect the cage across the X. If we reflect it only across the X, we get what looks like this B cage. And then we would reflect it across the Y, which gives us what looks like this A cage. And you can see that this would get transported to here, which then, I did that wrong. Reflecting across the X, yeah, this would end up here. No, but then that would end up there. So I really, I guess that's not a good way to describe it. I think you have to just say to reflect across the diagonal that's appropriate to get the other cage. So in this case, this reflects to here. I think that's what we have to do. Because the example says this is green. This is the only thing I can think of for how this reflection works. Is we have this diagonal line here. If you imagine that as a mirror, this would get mirrored to here. And I don't know, my spatial reasoning is not good enough to explain that better, but we're just going to have to go with it. And so this B cage and this B cage, this would reflect to here. This reflects to here, and this reflects to here. You're reflecting across, in this case, this diagonal line. That's the only thing I can think of. All right. Well, those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, 7 cages in 3 are gimmies. They have to be 1, 2, 4. If you want to kind of think about that, like how would I determine that? It can only be 1, 2, 4 without like trying to case check it. One of the easiest ways to do it is think about what the smallest that you can add to with 3 digits is. And that is 1, 2, 3, which adds to 6. 7 is 1 higher than that. Without repeating a digit, I need to add 1 to one of these digits. So I can't add 1 to the 1. That would give us 2 2s in the box. I can't, or in the cage. Can't add 1 to the 2. That would make 2 3s in the box. So I can only add 1 to the 3 and make it a 4. And then now 1, 2, 4 is the only way to add to 7. All right. And so that means the rest of this box is 3, 5, 6. Now we know this goes to here. So this is, Whoa. This is also 3, 5, 6. And then this goes to here. This is 3, 5, 6. And in fact, I might want to color it. Let's give that a color. Let's give that a color just so that we know how this reflection happens. We also have a bunch of C's. These C's are all the same digit, but I don't know if we can prove they aren't purple. In fact, they are purple. These are purple. So if you think about it, let's give it a gray color to start with. But this gray and this gray look up into here, and this gray looks into here. And so actually this is the same. This is where it's placed. So these are actually the purple. And they're also 3, 5, 6 as a result. And now these D's, let's give them gray again. Are there more D's? No. So what do we want to do with these D's? I'm not sure. Okay, I'm not going to do that yet. Okay, we know that green and orange are different because they're in the same cage. And so green needs to go in this box somewhere. So it can only go here. That's also 3, 5, 6. These add to 13. I'm trying to decide if I want to think about 13. 13 and 3 is pretty open. It's actually not that open. Okay, well, let's do 15 in 3. What is the maximum that we can put in 3 digits? 4, 5, 6. 4, 5, 6 adds to 15. So that's what this is. This is a 4, 5, 6. And 4 is in one of these two. It's going to claim the box. So if 4 is in one of these two, these can't be 4. This is a 1-2 pair, and this is a 4. And so 4, 5, 6 tells us this has to be the 3. So we actually know that purple is 3 now, which is very handy. Means green. We get 2 deet dudes. Very nice. Simultaneous. Green is 5 or 6. Do we care that these are the same? We know it's not any of our existing colors because this box here has all our colors. So we can just give this red. We know these are the same digit and they are not purple, orange, or green. We also know D is not any of our existing colors and it's not red either. So we can make that yellow. And so this is our final digit, I guess. We can call that blue. So what's missing here? The orange is missing here, and then we need blue and red here. Red can't repeat in the box, or not in the box, so in the cage. So this has to be blue, and this is red. What if we can color the whole grid? These might be interesting because they're not red. Okay, so if red doesn't go in any of these, it's in one of these two. I'm not sure which one. Blue looking up here means one of these is blue. Yeah, so blue in this box is actually limited. If one of these is blue, we need a blue down here somewhere, but this is preventing from being there. So that's our blue. The 2 colors left are orange and yellow. I don't know the order. These 2 oranges do look up though. So orange is one of these 2. All right. Do I need to do Sudoku instead of coloring? I mean, I'm basically trying to do Sudoku with coloring, but let's think about 13 then, because 13 is 2 less than 15. So there's going to be 2 ways to add to it. We can subtract 2 from the 4, giving us 2, 5, 6. Or we can subtract 1 from the 4 and 1 from the 5, giving us 3, 4, 6. Well, it's certainly not 3, 4, 6. 3 and 4 are gone. Wait, both options use the 4 for 13. What did I miss? The 5, no, sorry, without the 4, yeah, yeah, 2, 5, 6 was the way to do it. Yeah, sorry. Without the 3 and 4, we got to do 2, 5, 6. So this is 2, 5, 6. So all these are 2, 5, 6. Oh, this blue ends up here because of our reflection. So are we limited on what these can be? Ah, yeah, we said that this needed to be orange or yellow, but it actually can't be orange because it reflects here and sees an orange. So this has to be yellow, and then this is our orange, and now we know orange is 4. Nice. All right. That places the 4 here, which is orange. This 5, 6 is the same as this 5, 6 through the medium of this one. This is the other one that isn't green, so this has to be the green one. I guess it's either blue, red, or yellow. This is not blue. Oh, the 2 blues looking up to make this a blue. So blue is 1 or 2. If we look cross-reference here, it can only be the 2. Can't be the 1. So that's our 2. This is that other 5, 6. We get our 1. I mean, I know it's red, yellow, but I don't... Actually, this can't be yellow. So this is red. This is yellow. So all our yellows are 1s. Okay. All our reds are the other 5, 6. So this is red. This we need the green 5, 6. This column. This column we need the 4, which is orange. This column we need the 2, which is blue. This column needs the red 5, 6. And this row, we can just finish the colors. This row needs the green 5, 6. And this final one is our yellow 1. All right, now we just have to resolve the 5, 6s. I'm sure one of these sums does it. This will do. Oh no, that's not a sum. Sorry, this sum, that's not a sum. This sum does it, the 12. Okay, so this adds to 6, so green has to be 6. All right, so green is 6, and red is 5. All right. Nice puzzle, Scott. I just had to understand the reflection thing. The example only gave one option, but it took a bit for me to understand, like, we were reflecting, I guess, across a diagonal. But yeah, I'm not sure how that rule could have been better phrase. The example kind of forced it though. And it looks like I did it correctly. So there we go. Well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.